So let's look at global mathematics. But before we look at global mathematics, we need to look at the globe itself. Now, if this is my Earth, we have this line called longitude 0 degrees. And then this one is also latitude 0 degrees. So this is to determine the north and south is based on the latitude 0 degrees. So this is north and this is south. And this is west and this place is east. And these two lines, the longitude or the latitude 0 degrees, are the great circles. So this is also another great circle because they divide the Earth into two equal parts. Okay, so this place can be, let's say, longitude 20 degrees, 20 degrees. And then these are the small circles because they cannot divide the Earth into two equal parts. So this place becomes, let's say, 20 degrees north, and then here is 20 degrees south. So if I am let's say we are finding, we are doing a question on similar longitude. For example, longitude 20 degrees east. So this is 20 degrees east. So let me put E here. Longitude 20 degrees east. And then this can also be longitude 20 degrees west. Then 20 degrees west. Okay. Pause. So the great circles, these are lines that divide the Earth into two equal parts. The latitude and the equator. So the equator is bracketed as latitude 0 degrees are the great circles, and they have a radius of 6,400 kilometers. So the latitude, that is latitude 0 degrees, and the longitudes form the great circle. The latitude and longitude form the great circle. Pause. Now the small circles. So for small circles, they are the latitude, with the exception of the equator, because they are called the small circles in the sense that they can't divide the Earth into two equal parts. So the radius of these circles is denoted by r cos alpha, where alpha is the common latitude of the 2 points. Cos. So now let's look at the length of an arc of a circle. So the length of an arc of a circle is given by 2 pi r theta over 360 degrees. Now the 2 pi r, let me change this to the big R, because that is the radius of the Earth, which is 6,400 kilometers. Now, if you take the circumference of a circle, which is also given by 2 pi r. So you can see that the 2 pi r is the circumference of the circle times the theta over 360. Okay, so the theta determines the angle where the 2 points are being given. For example, if let's say this is assuming this is 20 degrees north. So there is a town here called town A, and then there's another town here called town B. And we have to find the distance between these 2 points, these 2 towns. Now, this is an arc. This from these 2 points, it's not a straight line, so it's an arc. So we are going to use this r to determine this length of arc to find the 2 points, the distance between the 2 points. Okay, since we can't go through the Earth's surface, the Earth's crust, to reach from, let's say, point A to point B. Okay. Now the circumference of the Earth, the circumference of the Earth is also estimated to be C equals 40,000 kilometers. 40,000 kilometers. So now we said R is the radius of the Earth, which is 6,400 kilometers. Now the theta, which is the angle, is the angle subtended by the arc, and it can be the sum or difference depending on the latitude. So for example, if the directions are different, example north, south, or east, west, we add the angles. And also, if the directions are same, for example north, north, or south, south, we subtract the angles. So let's look at this example. We have to find the shortest distance between the two towns, A, latitude 25 degrees south, and then longitude 30 degrees east, and then B, latitude 35 degrees north, and then longitude 30 degrees east. Sometimes it will be given as, let's say, A being 25 degrees south, and then 30 degrees east. Here, nobody should tell you that this is latitude and this is longitude, because for latitude, they are north and south. So the north and south determine the latitude, and then the east and west determine the longitude. Okay. So let's solve this example. Now we know that our length of arc L is equal to 2 pi r theta over 360 degrees. And then our r is giving us 6,400 kilometers. Okay. Now what about the angle theta? So we have 30 degrees east, 30 degrees east. So we will not consider this one, but we will consider 25 degrees south and then 35 degrees north. So let's come to this side. Now 25 degrees south. So if this is 20 degrees south, then definitely 25 degrees south will be here. So this is 25 degrees south. 25 south. And then 35 north. So if this is 20, then 35, let's assume this is 30, 30 north, then 35 also be here. So 35 degrees north. Now let's locate 30 degrees east and 30 degrees east. So if this is, let's assume this is rather, let me add one more. So let's assume this is 10 degrees east. And then, so in that case, this will be 20 degrees east. And then here will be 30 degrees east. Okay. So in such case, 30 degrees east. 30 degrees east. And let's see where the two lines are meeting. 30 degrees east is this one. And then 25 degrees south is here. So the two towns A, 25 degrees south, so this is town A. And then 35 degrees north. So 35 degrees north, which is also here. So we are finding the distance between this line along the longitude. So this one. Okay. So our length of arc, so this is an arc. This is an arc. So the length of arc is giving us 2 pi big R theta over 360. So since we have difference in the longitude, we are going to add the two angles. So 25 plus 35 should give us, this is 60 degrees. Now our length is equal to 2 pi r, the big R, which is, so let me add this straight away, times 3 points, which has been given 3.142 times 6,400 times 60 all over 360 degrees. Cos all over 360 degrees. Okay, so this into itself 1, here 6. Now this 2 into itself 1, here will be 3. Okay, so we have 3.142 times 6,400 over 3. So this on the calculator will be, okay, so from this on the calculator will be 6,703 kilometers. So that therefore the distance between town A and B is 6,703 kilometers.